All right, y'all. So like I said, 8.6 is going to deal with polynomial inequalities. And remember, inequalities will be less than or equals, greater than or equals. So we're going to look at polynomials involving these inequalities, okay? So I'm going to list out the steps I'm going to use to solve these. Because y'all remember, since they're inequalities, it's possible to have more than one answer on these, okay? So first thing we'll do is pretty much what we've been doing. We're going to set the polynomial equal to 0. Okay, so we've been doing that with our equations. Then we'll solve for the variable. So solve for the variable. So now where it's going to start changing is right here. So what I'm going to do, when I solve for the variable, I'm going to get, well, for pretty much most of these, we'll get two answers. The only time we won't get two answers is when it's going to be a repeating answer. So what I'm going to do, I set up a number line. Using the solutions. Okay, so for my number line, I'll have two solutions on most of these. So I'll have my A solution and my B solution. So I'm just going to write me a number line with whatever two answers I get, okay? Now what we do, we choose test points out of these intervals. So we choose test points and we plug those numbers back into the original polynomial to see if they're going to be true or false. If it's true in the section, we shade it. And if it's false in the sections, we don't shade it. So I'm going to use test points to check for true or false. Okay. Now, if it's true, then shade the section your number was from. Okay. Now, if it's false, then that section is not shaded. So what will happen if it's shaded, it becomes your solution. So if the area is shaded, then we write the answer in interval notation. Now, here's another part about the interval notation. If the inequality has a line under it for the equals, So if it's greater than and equals or less than and equals, we're going to use brackets around the number. So use brackets around the number if it is less than an equal or greater than an equal. Almost like doing the solid line, dotted line stuff when y'all were graphing, okay? And then I would use parentheses around the number if it's less than or greater than. Now, y'all, there's two different things that can happen. So all these are going to be solved by either factoring or square roots, okay? So there's two things you got to watch for. If we only get one solution for the polynomial, then that is the only number excluded from the domain. Okay? And there's one more thing that could happen on these. What if we cannot factor the polynomial or solve it and get real numbers? So if the polynomial does not factor, then we have a no solution. Represented by that symbol right there. So it looks like a zero with a line through it. This is our symbol to represent no solution in MATLAB, okay? Now, y'all, I'm going to say this. These intervals, there's two outcomes what they'll look like. The first possible outcome is it's going to shade in the middle. If it shades in the middle, then your interval will look like that if we got equals in it, or it'll look like parentheses if it doesn't have the equals on it, okay? So if it's only shaded in the middle, it's going to look like one of these two answers when you're done. The other possibility is if it shades on the ends. And y'all, if it shades on one end of the number line, it's going to shade on the other end of the number line, okay? And it won't shade in the middle. So it'll either shade in the middle or it'll shade on the ends. If it shades on the ends, our intervals that go from negative infinity to the number, and in union from the second number to positive infinity. Okay, so the shaded areas would be represented. This is the left shaded area, and that's the right shaded area. We can't union from A to B in here because it's not shaded, okay? So they'll look like that if they got equals. And then it'll look the same way with parentheses if it don't have the equals. So, okay, if I get two solutions, it's got to be one of these two patterns when we're done. All right, y'all, so I'm going to let y'all write them steps, and then we'll start solving these inequalities. And I think there's like 7 of them in the homework. So since this is a short section, I'll go through all 7 of these, okay? All right, y'all, so I'm going to start number 1 here. So what these exercises will say, solve the following inequality. And I'll show you the tricks. Is like on the test points, there's only one number I check every time, and that's 0. And depending on where that 0 is located, will let me know how to shade it, okay? So y'all watch this. For number 1, they're giving me x minus 2 times x plus 3 has to be less than 0. So this one's already factored. So what I do is I take both of my factors and set them equal to 0 to solve. Once I get these two solutions, I'll set up my number line, okay? So really on this first one, I'm just going to add 2 to move it. And we get x equals 2. And then on the second one, we're going to subtract 3 to move it. And I get x equals -3. So I'm going to set up my number line based on them two solutions. And I'm going to get my numbers in order. So -3 would be first over here. And then my +2 will be right there. So anything to the left gets more smaller, -4, -5, -6, so on. Anything to the right, 2, 3, 4, 5 towards infinity. In the middle would be what? -2, -1, 0, 1, and then my 2. So y'all, here's what I do to this. I look and see where 0's located on here. Well, 0's in between -3 and 2. So what I'm going to do is test the interval where 0 was located. And I know 0 comes in between a -3 and 2, okay? Now, if I put 0 into this equation and it's less than 0 is my true solution here, then I'm going to shade where that 0 was located. Now, if 0 is put into here and makes this a false statement, then I'm not going to shade where the 0 was located, and I'll shade the outside areas. Okay? So if this one's not shaded, that means both of these will be. If this one is shaded, then both of these won't be. So let's put a 0 in and see what we get. 0 minus 2 times 0 plus 3 has to be less than 0. Now, y'all, you can use any number you want. I just find it easier to use a 0, okay? So this will give me -2 times a +3 has to be less than 0. And y'all look at that. -2 times 3 gives me -6 less than 0. That is true. So since that's true, I'm going to shade the section where 0 located. So if I do that, let me draw my number line again. So over here was -3, and here was 2. So since 0 was in the middle and it was true, I'm going to shade this section where the 0 was located. And now all I got to do is write this in interval notation. Now remember, I said this one would look like a single interval. You won't have no unions on it because it's only one section. But the first thing I need to know on this, because all I got is the numbers, do we want to use brackets or do we want to use parentheses?
Parentheses.
Parentheses, there you go. And y'all, my interval goes from -3 to a +2, and then close my parentheses. And y'all, that's it. That's number 1. Okay, so like I said, if 0 would have been here and it was true, I'd have shaded the outsides, okay? You just got to find where that 0 is. Now listen, you could use any numbers you want. If you wanted to try -4 here, a 0, 1, or something here, and a 3 here, you could test them all, but those sections would have been false. All right, so now this one has an x squared minus 14x plus 33 greater than 0. So this one's not factored like this first one, so I'm actually going to factor this one. And when I factor it, I'm going to get it set equal to 0 here, okay? So the x squared is an x and an x. I'm focusing on the last sign here. That is a positive 33. So I'm focusing on the positive. It tells me these factors have like signs, like the middle. So both of these will be negative. And then I'm looking for factors of 33 that'll add to get 14. So now remember, you can find the factors given the y equals 33 divided by x. But y'all, 33 is 1 and 33 and 3 and 11.
11 and 3, yeah.
So let me see what my chat's saying. So 11 and 3, yep, that's it. And don't matter where we put them because they're both negative, okay? All right, now set these equal to 0, and we'll get our two solutions. Oh, they're both going to become positive, right? So add 11 here. X is 11, and then add our 3 here. And x is 3. So we know what our number line is going to look like. So check this out. If I'm going to check 0 this time, well, 0's not in the middle this time. 0 is going to be over here before the 3. So I know 0 is in this section over here. So if it's true, we'll shade the end and the other end. If this is false, then the only place that'll shade will be the middle. Hey, also remember what I'm going to do. Take this original polynomial and see if this is true for that 0. So that's going to give me 0 squared minus 14 times 0 plus 33 has to be greater than 0. And y'all see why I like zeros? Because 0 squared is 0. 14 times 0 is 0. So basically, this becomes 33 greater than 0, which is definitely true. So since that's true, we got to shade the left end and automatically shade that right end. So let's see, that'll give us, here's 3 and 11. So we got to shade both the ends here. And y'all, that's the biggest thing you got to remember, that if you shade one end, you're definitely got to shade that other one, okay? Alrighty, at that point, I'm going to write it in interval notation. So remember, this one starts at negative infinity over here. And then it goes up until the 3. So y'all, on this one, parentheses are brackets. And remember, all I got is a greater than there.
Parentheses.
All right, so parentheses. So that's that side. And then we union it for the right side, which starts at 11 and heads towards positive infinity. Okay, so notice one shade, one interval. Two shades, two intervals, okay? And I'll tell you, the trick is they're just going to change up these polynomials each time and make us do a little bit more work each time on them, okay? All right, so what's next? Number 3. So at 3, they give me a x squared minus 4x minus 18 is greater than or equal to x minus 4. So y'all, the first issue is, before I try to factor it, I need a 0 over here. So that means both of these got to move. We got to subtract that x from both sides. And we got to add 4 to both sides. Okay, so 2 things to move on this side, add their opposites to the other side. Because y'all, that's the biggest thing we got to get is that 0 here, okay? So bring down the x squared. Negative 4, negative 1, give me negative 5x. Oh, let's see, negative 18 and 4 give us a negative 14. All that is now greater than or equal to 0. So since we got our 0 now, we can try to factor that, okay? So that x squared is an x and an x. All right, now look. The last number is a negative 14. So you got unlike signs. Now, since that's minus, I want factors of 14 that'll subtract and get a 5. So let's see, that'd be 1 and 14, 2 and 7. So since that's a minus, they got to subtract and get 5. So that's 7 and 2. Now also, the larger number will have the same sign as the middle. So the 7 is negative and the 2 is positive. And y'all really want y'all to focus on the last sign to determine whether these are adding or subtracting, okay? All right, so now what? Set both these equal to 0. And we will solve these by subtracting 2. So that x is that negative 2. And then here, adding our 7. And x is a positive 7. So the number line. Let's see who's first. Is that negative 2 will be over here somewhere. And then my 7 over there. And y'all, I'm going to keep using 0 because I know 0 is in between those two numbers. So I'm going to test 0 again. And I'm just going to plug it into this original equation and see if it's true. Now, you can either use this original one or the one before we started factoring, okay? But I always use the top one. So I'll have a 0 squared minus 4 times 0 minus 18 is going to be greater than or equal to 0 minus 4. Well, y'all look, all the 0 stuff is gone. 0 squared is 0. 4 times 0 is 0. So all that's left is a negative 18. Greater than or equal, and look, 0 minus 4 is negative 4. So that's why I like using zeros, because when you plug in zeros, it's basically whatever that number was is your answer. But now here's the question. Is negative 18 greater than or equal to negative 4? True or false?
False.
Good job. That is definitely false. So since 0 was in the middle and it was false, that means we got to shade the outer edges. So 0 is false, so we're shading the outer edges. Which means this one's going to start at infinity again, over here at negative infinity, until we get to that -2. All right, y'all, parentheses or brackets? Let's see, what do we have? Oh, this time we had greater than or equals.
Brackets.
All right, and then we'll union that from what, to 7 to positive infinity. Okay? Because y'all, what'll happen if you put -2 into the equation, it won't be greater than, it'll be equal. It makes the equal part true. And see, on the ones where we use parentheses, those numbers, there wasn't an equal in it to make it true. So that's why they use parentheses, because those ones weren't technically included in the solution. All right, y'all, so what if we had an x squared greater than 16? Now, I'm not going to lie, you could get a 0 over here and factor this one. You'll get x squared minus 16 greater than 0, and then you could factor that perfect square stuff. But really, there's one move to do this one, and we could be done. Because I got an x squared and equal to a number. The only move I need to do with that is a square root of this. So we could do this as square roots by doing the square root of x squared equals the plus or minus square root of 16. You just got to remember, when you take the square root of a number, it could be that positive number times itself, or it could be a negative times itself. So that, y'all, I get x equals a plus or minus 4. Now, that's the easiest way to solve this. If you like factoring, I'll write that over here as the other way. If you want to factor this, you would subtract 16 from both sides and get x squared minus 16 greater than 0. And then this would be what we call the difference of perfect squares. So the x squared would be an x and an x. Last number is negative, so one's plus and one's minus. And then to find the factors that you need, you'll just take the square root of 16 and get a 4 and a 4. So I won't go further, but at that point, you would set x plus 4 equal to 0, x minus 4 equal to 0, and that'll give you the same two answers as we got over here, okay? All right, so either way, I think this is quicker, is why I like to do that square root stuff. Now, you also had a -4 and a +4. So that means my 0 is in between those two numbers. But y'all think about this. That's a 16. So these answers we got, 4 squared is 16. Anything less than 4 ain't going to be greater than 16. Like 3 squared is 9, 2 squared is 4. So those are all false. But when we start looking at numbers bigger than 4, like 5 squared is 25, which is greater than 16. So I'm expecting this 0 to be false in the middle, okay? So 0 squared has to be greater than 16, which means 0 greater than 16. Well, y'all, that's definitely false. So that means I'm not going to shade where that 0 was located. I'm going to shade the outsides. Okay, because any number I shaded, if I square it, it's going to be bigger than 16. Like 5 squared was 25, 6 squared is 36, and they're just going to get bigger as I head out towards those infinities, okay? So, interval notation starts at negative infinity, goes up to our -4, greater than is parentheses, and then union from the +4 to positive infinity. So y'all, they're not bad. You just gotta keep up with your intervals, okay? Now, the next one is really similar to this one. 225 minus x squared has to be less than or equal to 0. So y'all, this one's on y'all. What would y'all do to solve this for the x? All right, so square root, good job. So to square root it, what would you do here though?
Move 225 to the other side.
Okay, so I'm going to subtract 225. So that brings down your negative x squared less than or equal to a negative 225. All right, so now what? Because I'd probably do one more thing before I square root that.
Do you have to change the sign since you moved it over?
Uh-huh. And then I'm dividing by negative, and let's see, y'all are saying, so we're dividing by negative. And since I'm dividing by negative, looks like we're going to flip this little inequality around now. Good job, because we're dividing by negative. We're going to flip that around. So that x squared is actually greater than or equal to 225. So that's the trick. Y'all do what you said. Get the x squared by itself and then divide by that negative, which means this changes. So now I'm going to take square roots. And that's why I leave the greater than or equals until I'm ready to do the square roots on this one, okay? So I know that's an x. So what's square root of 225? So 15, good job. So look, I got my interval. I've got a negative 15 and a positive 15. So now I'm going to test my 0. So let me go over here. So I'm going to test 0. Since that 0 is in between those. So I'm going to do this. 225 minus 0 squared is less than or equal to 0. So is this going to give me a false or true statement? Because it looks like all I'm going to have is 225 less than or equal to 0. So y'all true or false?
False.
Right, so that is false. So since it's false, my number line, well, let me ask y'all this. Am I going to shade the middle where the 0 was located, or will I shade the outside edges?
The outside.
All righty. And y'all, I guess the last thing I need to know from y'all, brackets or parentheses?
Bracket.
Brackets.
All right, y'all, so negative 15. Brackets because of that equals, good job. And then union that from 15 to positive infinity. So y'all, these ain't that bad. Y'all are getting the hang of these. Now the next two will be the two that I did the stars by when I did my steps, okay? Remember, I had 2 stars. So let's see. I'm gonna let y'all catch that up and then we'll move on. All righty, so let me get everything up here. So number 6, they got a 14x minus 49 minus x squared is less than 0. So y'all, before I try to factor that, there's one thing I would do to this. Well, probably 2 things I would do first. First thing, I don't like that order. So I'm going to put them in order by bringing that negative x squared to the front. And then my positive 14x. And then minus my 49 has to be less than 0. And if you remember, I don't like that x squared being negative. So we got to divide everybody by -1. And once again, since I'm dividing by negative, I'm going to reverse my symbol so that it now looks like a greater than. And y'all watch this. X squared is positive now. Unlike signs, make that negative. Like signs, make that a plus. And it's greater than 0. So get them in order and then take care of that negative, okay? So now we're ready to factor this. So the x squared is an x and an x. Now, the 49 is positive. So both of these signs will be negative like the middle number. So y'all, all I need now, how about this? Factors of 49 that'll add to equal 14.
Seven.
So 7 and 7, good job. Uh-oh, so this is one of those repeating factors. So all I got to do is solve one of those. So remember, we said if we only get one solution, which is all I'm getting out of this, is an x equals 7. So I don't even have to set up my number line because I've only got one number. And we said if we only got one solution, that's the only number we gotta exclude. Okay? So if you was to look at that graph of this, like that's your x-axis, and say this is 1, 2. Y'all remember when we was doing that tangent, or if it crossed over the x-axis? Since these were repeating factors, their multiplicity would have been 2. So that means it would have came down and touched the x-axis at that 7. Okay? Which means it don't equal 0. It equals 0 if it's on the line. Well, they don't have an equals under this. All they got is a less than or greater than, right? So everything else is greater than, but the 1 point, since it's on the line, equaled 0 and not greater than. So that's why one solution, that's the only number I gotta exclude, because that's the only part that ain't greater than 0, okay? So if I'm excluding one number, I'm going to start at negative infinity. And this is just like doing the domain problems. I go to 7, parentheses. So the parentheses kick it out, remember, because it ain't got the equal in it. And then from 7, we go to positive infinity. So on your number 6, you're probably going to get repeating factors, and that's the only number you're going to kick out. See, everything else does make it true. That's why we go from negative infinity to that number, and then from it to the positive. All right, y'all, so let's try this last one. X squared plus 22 less than 8x. So I'm interested. What would y'all's first move be on that?
Move 8x to the left.
So that'd be what, subtract it. There you go. All right, so I'm going to put them in order here. So my x squared, then that negative 8x, and then that 22. So technically all of them got to be less than 0 now. All right. So if we're going to factor it, x squared will be an x and an x. This is positive. So positive means both factors will be negative like the middle. All right, y'all. So what I need are, looks like factors of 22 that'll add to get me an 8. So what factors of 22 will add to get an 8?
5 and 3. No,
Oh, what was they?
no, I don't think that's right. 5 and 3.
Let's see, we got 1 and 22, that didn't work. What else would go into it? Oh, 2 and what? 2 and 11.
Yes.
That looks like it to me. But guess what? None of those are going to add to get me an 8, are they?
No,
Those they're 23. Those are adding to get 13. So if I could not factor it, what did we say?
Do not factor.
So it does not factor, but what's my actual answer going to be?
It has to be represented by 0.
Exactly. This is a no solution. If it's a no solution, we use the 0 with the line through it. Now, when you click in the answer blank, MathLab shows this down there, like where they have the square root stuff and the not equals and all that. You'll see that symbol down there. So use that and don't write no solution. Use that symbol, okay? All right, y'all, that's the 7 y'all got to worry about. I'm keeping it light this week because of that test, okay? So knock out your 8.6. That way, Thursday night, all we got to do is review for test 3, and y'all can focus on that. And remember, I moved the due date for test 3 to next Tuesday, from Sunday to Tuesday, okay? Let me see, what's today? 9, 10, 11. So I moved it to the 16th instead of the 14th. So let me write that. Test 3 due the 16th.
Sounds good.
All right, y'all. So any questions out of y'all for stuff?